Third example, we have a pole tilts towards the sun at an angle of 8 degrees from the vertical, and it casts a 22-foot shadow. The angle of elevation from the shadow to the top of the pole is 43 degrees. How tall is the pole? Okay, an awful lot of information we have to go through there. If you notice, it's much harder to do these types of questions because of the amount of work we have to do to create the diagram. So we know obviously that we have the ground and we have the sun somewhere shining down, and so we will have the sun. We have yellow here, so here's the sun and it's shining down on something. We have a pole that tilts towards the sun. Okay, so I have my straight line and it is tilting. So here's my pole and it is tilting towards the sun, and I'll make it thicker. So here's this poor pole. It's tilting towards the sun. And it says at an 8-degree angle from the vertical. So what they're talking about when they're talking about the vertical is almost like an imaginary line. So if I went straight up here and I created a 90-degree angle, what they're talking about for the 8 degrees is they're talking about from the vertical. So it's right in here that they tell us is 8 degrees. So we know that we have then in our diagram, we have obviously our 90 degrees, and we have this little location here is going to be 8. Okay, so that's 8 degrees, and that is 90. So we could actually figure that all out, but I'm not sure if we need it. The angle of elevation from the shadow to the top of the pole. Okay, so if the sun is shining down here, it means I have a shadow that's going on down below. And so that would be my shadow down here. Okay, and I'll just make it a little bit thicker. So here's my shadow. And if I actually measured it, it said the angle of elevation. Okay, so if I'm looking up, the angle of elevation to the top of the pole is 43 degrees. Okay, now you can see there's a fair amount of work to come up with this diagram. Okay, so that's why it's so important to do your diagram, because it's actually worth marks if you want to look at just marks. So this is going to be 43 degrees according to the information given. Okay, so what's going on here? They want to know how tall the pole is. So they actually want to know how tall this thick pole is. And if you notice, it doesn't want to go where I want to go. Okay, so I want to know how tall the pole is. So I want to know the length of P. Now, let's take a look to see what we know. Do we know any other measurements? Well, you would think that maybe I would need to know another angle, maybe. And remember, that was one of the things that we needed to look at. Okay, so if we look at our triangle, we know we've actually done a little bit of calculating. This purple here we know is 98 degrees. We could find the angle at the top, which would be this one, and that would be, of course, our 180. Take away the ones that we do know. So up you go, pen. 180. Take away our 98 and our 43. So we know that that angle then equals this. So we have that angle as being 39 degrees. Now, if you find that it's too cluttered, you can actually draw another little triangle if that would make your life easier. And sometimes, as I said, I do that. If you notice, I'm not using a ruler, but that's 43. I know that this is 98. This is what I want to find. And I have this as 39. Now I still don't, I know all my angles, but I'm wondering if there's not another piece of information that I've missed. Okay, so I'm going to go back to the question. A pole tilts towards the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. So we haven't dealt with that shadow. So the shadow is down here, which then transfers to over here on my diagram. So now what law do I use? Well, I have three sides. No, I have three angles. If I had three sides, I could use the cosine law. Now, do I know a side and an angle directly across? Yes, I do. There it is there. So I know I'm going to use the sine law. So the sine law is what we're going to be using. And so now it's just a matter of writing it down. So I'm going to use P over the sine of P equals A over the sine of A. And I could actually put B over the sine of B if I want to. Don't think I will need it because I don't think I have enough information and I'm not really interested in that. But let's see what we have when we do that. When we do that, P is what I want to find. I have angle P, which is 43 degrees. A, I'm going to say is my 22 because I know that, over the sine of 39, so the angle directly across from 22. Now, I do know angle B, but I don't know anything about side B, and I really don't need it because I have enough information here to solve. So we're going to cross multiply and then divide just like we have been doing. So I have P sine of 39 equals 22 sine of 43. And to get P by itself, I'm going to divide both sides by sine of 39. And when we do that with our calculator, we end up that P is approximately equal to 23.8. Okay, so that means that our pole is approximately 23.8 meters long. So fairly, or feet actually long. So good size pole actually. So I'm just going to type that up. The pole is about 23.8 feet long. Okay, so there's a few questions for you as far as examples go. As I said, every question is different. Sometimes the hardest part is getting the picture. Okay, so if you're unsure about your picture, make sure you ask before you actually do all this work, and then you discover, oh, I put that angle in the wrong spot. Okay, good luck.